Hi everybody and welcome to today's YouTube Live. We're going to be focusing on Maths Paper 2 today. Thank you to everyone who joined in on Monday to look at some of the Paper 1 topics for higher level Leaving Cert Maths. If anyone did miss our revision class on Monday, the recording is up on our YouTube channel, so you can have a look back on that if you missed it. And thank you for anyone who did send on any questions after the class, and I know I got back to most of you through our Instagram page. So as always, if you do have any questions throughout the next 2 hours, if you go onto our Instagram, our most recent story, you'll see a question box and you can put in any maths related questions there, whether it's to do with, paper 2 or just maybe a particular topic of something that you would like a bit more information on. And I'll try and either answer it during today's revision class, or I will do it, as I said, through Instagram as well. So just to start off with, we're going to start off in the same place I started Monday's class, and this is just a quick refresher again, just to advise everyone about our 2021 papers. Just a reminder that in section A of paper 1 and paper 2, you are going to have to do 5 out of 6 questions this year if you're sitting your Leaving Cert in 2021, and each of these questions will be worth 30 marks, and again, similar format to previous years. And then for section B, which is the application section, you're going to have to do 3 out of 4, and these will be worth 50 marks each. So again, as I mentioned on Monday, we've been told that the amount of material presented in each question will be reduced somewhat. So when you are revising, I suppose it's just to be aware that when you're looking at some of the exam questions in section B in particular, have a look at how many marks are going for the question, and I suppose just remind yourself that in this year's exam they will be 50 marks rather than maybe some of the higher amounts. I don't think it should really change how you're studying. I think you should still look at those section B questions, because it does help you to kind of see the more application style questions that could come up. But I suppose, as I mentioned on Monday, we probably won't have as much crossover between multiple sections as we may have in previous years. Moving on then to our topic breakdown. So again, this is very much the same as what I showed in Monday's masterclass. So for paper 2 then, the kind of topics that we were going to be looking at, we won't be looking at every single one of these today, but the main ones we're going to be talking about will be probability and statistics, and then I will also talk about the line and the circle today. The other areas that could come up in paper 2 is geometry, which includes your constructions and theorems, as well as your shape angle facts. We've got trigonometry, transformations and enlargements, and length, area and volume. So you will sometimes hear paper 2 being referred to as the shape paper. It has obviously a lot of truth in it, but there is more than just shapes that come up on paper 2 that we're going to have a look at today, and in particular your probability and statistics does also form quite a large amount of the paper. Okay, so just a few exam tips. Some of these I mentioned before, but some are new as well. So look, again, revise the basics. Please make sure you're spending time over the next few weeks and months going back over, making sure you're happy with your solving equations, your factorizing, your angle facts, like basic things from your junior cycle that you should know and be aware of. Again, make sure you're reading your questions carefully, looking at exactly what we're being asked to calculate. Again, it's all about the attempt marks. I don't think really there is one paper over the other where attempt marks are more easily gotten or anything like that. But what I would say about paper 2 is I sometimes find when I'm correcting work for paper 2 topics that there are easier attempt marks in certain ways to be earned, because we have, and it brings me on to the next point, we have our formula tables, which are more so in use in paper 2. Now obviously we use them in paper 1, but in paper 2 we know that we have all of those area, surface area, volume formulae, and obviously we also have your circle and your line formulae. And it can be frustrating sometimes when you're correcting paper 2 topics in particular, and a student has been asked to calculate something and the formula is literally there in the book beside them, but they haven't written it down and they haven't attempted to substitute into it. So that would definitely be my number one piece of advice for paper 2 and paper 1, of course, is to think about the chapter or the topic that the question is based on. And if it is relevant to a topic in your formula tables, open them up in front of you. And even if you're not 100% sure what formula you're supposed to use, like, you do a bit of kind of trial of elimination and try and figure out what may or may not work. There is only a certain amount of formulae that we have in the Leaving Cert maths course. So try and, I suppose, use a little bit of common sense and say, well, it has to be one of these. Let's do my absolute best to try and figure out which one it might be. And then always do try to make some type of relevant substitution into your formulae. Now, I'll talk about this a little bit more when we're looking at some exam questions. But for example, if I give you a really, really basic example of being asked to come up with the equation of a line, and let's say for whatever reason you can't figure out what the slope of that line is, but you do know a point on that line, instead of giving up or just writing down the equation of the line and stopping because you can't finish the question off, go and substitute in that point on the line and just leave the slope as m, because then the examiner can see that you have made some relevant substitution into your formula, and you should be able to be awarded higher marks than if you simply just wrote down the formula and didn't maybe do something with it. So do always try and engage and substitute into the formula where possible. Very same as paper 1, you've got 300 marks on your paper and you've got 2.5 hours to do it. So again, as I said, very much an asterisk on this, but the absolute maximum then you'd want to be spending on each of your question is the amount of marks divided by 2. So again, the maximum you should be spending on paper 1, on section A, is 15 minutes per question if you're going to just do the 5 of them, and 25 minutes per question for the 3 on paper on section B. But as I did mention in our previous masterclass, if you do think you would like to attempt some extra questions, you may want to slightly reduce those times, or you might decide, I want to spend 5 to 10 minutes at the start of the paper, reading through the questions, which would be quite a logical thing to do. So you'll need to factor that in as well. So to be honest, I would be very much looking at those times as saying that's my upper limit that I know I have if I really, really need it, but I probably would want to be, spreading it out. And again, what we will notice is some topics will be more confident on than others, and you can kind of fly through the questions. Others, you might need to spend a bit more time getting to grips with the question. Okay, moving on then to talk to you about the topics then, as I did with paper 1, that have come up. And again, if you would like these notes after today's masterclass, if you put your email in the Google Forms that's in the description of this YouTube live, you will be able to receive these notes after the class, okay? So, and anyone who did attend our paper 1 masterclass, you should have received your notes on Monday evening. So if anyone didn't receive those notes, just make sure you have filled out the Google Forms from Monday's class. Okay, so look, again, this is just a broad overview. I'm using very broad titles for each of these sections, but it's just to give us a bit of an idea of the topics that have come up. So you can see, if we start with the kind of orange color and the red color of your circle and your line, you can see that you're gonna have those at least once, if not more, every single year. And I think most people, in fairness, if you've done any type of work with your exam papers, you would know that that's the case. Trigonometry, you can see, comes up as kind of its own question, but also may come up as parts of other questions, because it does obviously, cover such a large broad area of the Leaving Cert curriculum. Probability and statistics I've just coloured in the same kind of dark blue colour, and again you can see that they also come up at least 3 times every year in some shape or form. And and yeah, they are very much an important part of paper 2. And we've got our constructions, geometry, kind of you're dipping in and out. It will come up probably in some way over the course of the paper. And again, just to note that you can see in kind of the non-coloured in sections there, differentiation has come up, sequences and series, and you will see little bits and pieces of paper 1 throughout paper 2. So it's just to be aware that, and I haven't written them all down here by any shape or form, but it's to be aware that yes, while paper 1 you'll be finished with, you still will probably have to use some of the skills from paper 1 going on to paper 2. Okay, so that's kind of just the general overview of paper 2 and some general kind of tips. Hopefully that's useful. And I suppose, look, the main thing I would say compared to other subjects, you can't predict too much about what's going to come up on paper 1 and 2, because everything pretty much comes up every year apart from maybe 1 or 2 topics. So again, that's why it's so important to be comfortable with as many topics on the Leaving Cert as possible. As I mentioned on Monday, some of you may have already made decisions with your teachers or maybe yourselves about topics that you may or may not be leaving out. But I suppose what's important to look at, from here is a lot of these topics do feature across section A and section B, so I certainly wouldn't be leaving out more than one topic. And I'm sure when they're making the paper, they've taken that into consideration as well, that students may not be covering the entire curriculum, but I just wouldn't be leaving out more than one topic from paper 2. Okay, so what we're going to do to start off with then is we're going to look at probability and statistics. Now, the reason why I decided to start off with this, I did speak to my own 6th-year students about what topics they would like me to cover, and this was definitely one of the most popular ones. And I suppose the other reason I decided to start with this was because it generally is one I feel that students probably, particularly inferential statistics, students struggle with. And I suppose when I went to start teaching the new Project Maths curriculum a number of years ago, this was definitely a topic that I was kind of interested in because it confused me and it really challenged me as a teacher to know how to explain this as much as clear as possible. I suppose it's different compared to maybe your calculus and, some of the topics that are very straightforward. Here's a formula, sub stuff in, there you go. Whereas some of the probability and statistics stuff, it can vary, it can come up in lots of different ways, and I think it is one of those chapters that you do need to really engage with the exam questions to fully appreciate how it can come up on the Leaving Cert. Now, as always, I'm not going to have time to go through every single part of this. This is going to be a broad overview of probability and statistics, but I've just highlighted some of the main areas that I'm going to try and talk to you today about. So we're going to start off with probability. We're going to go through some of the permutations and combinations. We're going to talk about some of the important formulae, which I think everyone needs to know off by heart for your probability chapter. And we're going to look a little bit at binomial distribution. And then we're going to go on and look in statistics at some of the scatter diagrams or scatter plots and correlation coefficients. And I'm also going to do then a mix of probability and statistics where we're looking at the normal distribution, the empirical rule, sampling, hypothesis testing, 95% confidence intervals, etc. Because that's definitely probably one of the areas that I would be asked coming up to the Leaving Cert. That would definitely be one of the main areas that students ask me to go over. Okay, so we're going to get started. We're going to start with permutations and combinations. As I said, if you've got any questions, feel free to go on to our Instagram page and send them through to me, and I'll do my best to answer them later on in our live. Okay, so to start off with, I suppose, again, a question I get asked quite a lot is what's the difference between permutations and combinations? So to start off with, permutations are all the possible arrangements of a collection of things where the order is important. Now, again, it is hard sometimes to remember the difference between the two of them, but what I would say to you is when they come up in an exam question, you won't necessarily have to make that decision, because from practicing questions you'll see that the methods that you're going to use are quite different. I remember one student said to me at one point, oh, you can think about it like a permanent spot. So we're saying here that permutations is all the possible arrangements where the order is important. So you're kind of thinking about, right, I'm trying to set these chairs in a particular order, so the order is important. So when I'm looking at all the different orders, I'm giving them all permanent spots. So that's one way of maybe remembering that permutations is to do with where the order is important. And you will see in some of our permutation questions that we do use factorials to help us, and that's basically where we have something like this. Let's say if I had 3 factorial, and that just means 3 by 2 by 1. So it's the number multiplied by itself going downwards. So it's 3 by 2 by 1. So you're decreasing the number each time until you get to the number 1. And to show you this in regards to a question then, just to see how this could come up, how many ways can 3 of the letters A, B, C, D and E be arranged? So basically in a question like this, what you're trying to think is you've got these 5 letters, so you've got these 5 options, and we're trying to find a way of arranging them in a particular way. Okay, so it's how many ways can 3 of the letters be arranged. So what you need to think about then, and I've done it out here on the screen, but you need to imagine, right, there's 3 like seats up for grabs. So you've got this one, you've got this one, and you've got this one. And all you have to do is ask yourself, okay, well, how many possible options do I have for this first one here? There's obviously 5 letters. Well, one of them is used up, so then I have 4 options for this one, and I have 3 options for this one. So that's how I always go about these kind of permutation style questions, is where you're setting it up and you're thinking, okay, what are my options here? How many do I have left to fill these seats? You will sometimes see it being done like this, where we're saying we have 5 and we're picking the 3 of them. But to be honest with you, I think most of the time in the exams, it's probably more preferable to be thinking about them like they're seats, because you'll have a lot of other restrictions that you may need to put in place as well, which I'm going to show you now on the next slide. So in this question then, we're being asked to look at how many ways are there of arranging the letters in the word meaning. So the first one is nice and easy, if there are no restrictions. So again, what you can think about here, you could go out and do it out. So you've got 7 seats. 1, 2, 3, 4, 5, 6, 7, and you're just going to go down through them and say, well, how many options do I have for the first one? 7, the next one 6, etc., etc. And that's the exact same as using 7 factorial. It's just a quicker way of writing that out. But again, you don't need to write it out as 7 factorial. You can simply write it out as 7 by 6 by 5 all the way to 1, and you'll get the same answer. Okay, so that's the answer for the first one. The second one, if they must begin with N. Okay, so for this one, again, I've done it out here, but the important thing to remember is that, again, these are all your seats. So this still has your 7 seats. But because it has to begin with the letter N, okay, in this one, what we need to think about is how many of those there actually is, okay? So in this case, actually, there should be 2 there, shouldn't there? Because there's 2 letter N's. So that actually should say 2. So there's 2 letter N's to begin with, okay? And because we have 2 of them, we need to think, okay, well, there's only 2 possible options that can go there to begin with. But then we need to say, for all the other seats, how many other options are left? So what you need to think about is, we have just used up one of those N's, but there still is another N in the mix there that's just going to fall back into the original spot of all the other letters. So we're still only going to have 6 left for the next seat, and then 5, 4, 3, 2, 1. So if I go and work that out then, that's going to give me 1,440. Okay, going on to the next one. if the vowels must be together. So what you need to think about for this question is, because the vowels have to be together, you can sometimes nearly think about them as being kind of in like the one like seat almost, that you treat them as a collective in the one chair, the three vowels going together. So what you can do is you can kind of start off by saying, okay, I've got my three vowels in this question, 1, 2, 3. Yeah. So we're going to put the three vowels there, 3, 2, and 1. And then what we're going to do is we're going to say, okay, if I've put my three vowels there together in the first three seats, let's say, how many letters are left? So we have 1, 2, 3, 4 left. So then there's going to be 4 by 3 by 2 by 1. Now at that stage, a lot of people stop. But what you also need to remember is that those vowels can actually move around. So what we can say is, well, yeah, they can be in the first three spots, but they also could move down and be in these two, or these three, I should say. They could move down another one and be, oops, here like so. They can move down like this, and they can move down like that. So that's 1, 2, 3, 4, 5 different ways that they could actually be positioned along that group of letters. So therefore, that's why we multiply it by 5 at the end, to show the different ways that those three vowels can actually move along your seats. Okay, and again, we'll just work out the answer to that. 3 by 2 by 5, and that gives us 720. Okay, so that's just a quick example of showing you where you're kind of looking at your seats and you're trying to spread all of the letters amongst the spots with and without restrictions. Okay, moving on to the next one then. Okay, so we've got combinations. So combinations are selections, subsets, or choices where the order makes no difference. Okay, so in this one, it doesn't matter what order everything is actually being laid out in. We want to just figure out the different ways that that could happen. And this is actually found on page 20 of your formula tables. So again, it would be great to have your formula tables in front of you today. And you'll see it down the bottom of page 20, okay? And I suppose this is, these two here are the ones that we're probably most kind of concerned with, are the ones that we'll probably see being used the most. But again, it's to show you how this can come up. So the first thing that you need to be aware of is that sometimes students see this and they think that's a fraction, but it's not. So it could be something like 5 and 2. And what that means is it's 5 choose 2. So if you see something like that written, just be aware that that's not a fraction, that's saying 5 choose 2. And if you're trying to find that on your calculator, it's above the division sign on your calculators. So you're going to do 5, then shift on your division sign and 2, and that's going to give you an answer of 10. And you could also represent that in a slightly different way if you wanted to, using factorials. And again, you don't need to know this off by heart, it's on page 20, but you could actually set it up with 5 factorial over 2 factorial bracket 3 factorial. But again, your calculator does it for you there. That's just something to know, to be aware of, in case it came up in a question where you were asked to write it as a factorial. Okay, so then we're looking at a question. So there are 15 football players on a panel, including the captain. The manager has chose a team of 11. So they have to choose 11 players, obviously, for the team. How many different teams could he possibly pick if there are no further restrictions? So basically for that one, you're just saying, okay, he's got 15 players to select from, and he has to pick 11 of them. So simply that's just going to be 15 choose 11, and we can see that there are 1,365 different teams that he could possibly pick. And then the second one is if the captain must be included in the 11. So what you need to think about then is, well, now he actually doesn't have 15 players to pick from because he has to pick one for the captain. So that means he actually only has 14 players left to pick, but he needs to pick 10 of them now because the captain's spot is obviously gone. So you're going to do 14, you're going to press shift on your division sign to get choose, and 10, and that gives you an answer of 1001 for that one. So again, that's just an example of your combinations questions. Okay, so now what we're going to do is we're going to have a look at an exam question. Now, I suppose what I want to show you with this exam question is there is more than one way to do a lot of these questions, and I would definitely advise you to study your mark scheme as well, because sometimes you'll kind of be thinking, oh, do I need to use combinations or permutations, or what do I need to use? Sometimes it's kind of as simple as just looking at something as maybe a consecutive event. So it says a class consists of 12 boys and 8 girls. 2 students are selected at random from the class. What is the probability that the 2 students selected will be a boy and a girl in any order? Okay, so again, there's lots of different ways that you can approach this question. And again, it kind of depends on, I suppose, your understanding of probability and how you look at a question to start off with. So I suppose instinctively for myself, the way I would probably start this question is I'd say, okay, let me think of the different possibilities I have with this. So I'd be saying, right, so it's 2 students are selected at random. So one of the possibilities could be looking at the probability of picking a boy and then a girl. Or it could obviously be in the other order. So it could be the probability of picking the girl and the boy. Okay, so that's probably the way I would lay this out myself. So then we'd say, okay, what's the probability of this part first of all? So it's picking a boy and then picking a girl. So the probability of picking a boy from the class would be 12 out of 20. And remember, and you're going to use your multiplication there. So it's a consecutive event. It's this and this. And then the probability of picking the girl from the class next then would be 8 out of 19. Okay, because one of the students has been picked from the class. But then I'm going to add that on to the other probability of picking the girl first, because remember it said in any order. So that's going to be 8 out of 20. And we're going to multiply that by the probability of picking the boy next. So there's 12 boys, but now there's only 19 students in the class. And you can go and pop that into your calculator and you should get an answer of 48 out of 95. Okay, so again, that would be the way, if I saw this coming up on the exam, I would be using, and again, that's kind of junior cert maths really, you're using the fact that it's something and something happening together. So I'm multiplying the two probabilities, thinking of it like a tree diagram. And then I'm just doing it the opposite way around and I'm adding them together because they're 2 different probabilities, 2 different ways that could happen. Now, you could use your combinations there instead for this question. Okay, so another way you could do this, and again, it really depends on just what way you look at the question to start off with. You could say, okay, so I want to work out the probability of choosing a boy and girl in any order. So what you could do is you could say, okay, that's actually the same as saying 12 choose 1 for the boys multiplied by 8 choose 1 for the girls. And that's all over the probability of picking or the chance of picking 2 from the 20. So it's going to be 20 choose 2. And if you go and put that into your calculator, so if we do 12 choose 1 bracket 8 choose 1 all over 20 choose 2, we should get the exact same answer, which is 48 over 95. Okay, so both of those methods will work. As I said, personally speaking, I find the way I did it the first way the easiest for me to understand, or just to kind of, I suppose, the most straightforward way I can kind of see it. But again, using your choosing method would work perfectly there as well. And again, I would encourage you to look at your mark schemes and you'll see that there's probably even other ways that I haven't even thought about to do that question. Okay, and then part 2 says 4 students are selected, 1 at a time at random from the class. What is the probability that the first 3 students selected will be boys and the 4th will be a girl? Well, look, I'm going to approach this the exact same way I did the question above. So I'm going to say, right, the probability of, so the first 3 students will be boys. So you're saying boy and boy and boy, and girl is your last student, is your last selected person. And it is important that they are giving us that order, and it's not that it could be in lots of other orders. We'd obviously need to consider that if that was the case. So what we're going to do then is we're going to say, okay, starting off with the first boy. So it's going to be 12 out of 20. One of the boys is gone now, so it's going to be multiplied by 11 over 19. And then another boy is gone, so it's going to be 10 out of 18. And then how many girls are there? Well, there's still 8 girls there, but there's only 17 students left in the class. So if we go and multiply that out, and again, just to explain why it's multiplication in this question, is because it's consecutive events. They're happening one after another. So if you think about it like it's on a tree diagram, you're always going to multiply along the branches because it's consecutive events. And I'm getting an answer there of 88 over 969. Okay, so that's that question, guys. So again, there is another way using your combinations, which I'm not going to write out, but it is on the mark scheme, where you would do 12 choose 1 over 20 choose 1 multiplied by 11 choose 1 over 19 choose 1. But that really to me would seem like a bit of an extra hassle compared to doing it the way I've shown you there. Okay, so we're going to move on now, and we're going to look at some really important kind of formulae that I think every single Leaving Cert student should know off by heart going into paper 2 of your Leaving Cert exams, and even paper 1 potentially. You never know. So the next couple of slides, I really would recommend. The next 2 slides, I think it is. I would really recommend that you do try and commit to memory. It's more common sense. Some of them you will have worked with some of these since your junior cert. You may have remembered in your mocks even. I remember a question coming up about explaining the difference between mutually exclusive and independent events on the junior cert exam. Like, these are not necessarily extremely difficult concepts, but it's just sometimes they come up on the Leaving Cert and we're dealing with Venn diagrams, or we're dealing with kind of representations of different sets using their probabilities, and it can be difficult to maybe put your understanding of the concept into a formula. So to start off with then, we want to talk about mutually inclusive and mutually exclusive. Now, to be honest with you, most of the time we don't call things that are mutually inclusive. We just say there's 2 things that are happening. And these are events that have outcomes in common. So this would be the one that when you started doing probability and you started looking at, even in your junior cert, maybe at Venn diagrams, you may have looked at some examples of mutually inclusive events. But basically what we need to be careful of, just like when you went and learned about Venn diagrams back in first year, when you fill in the intersection of a Venn diagram, remember that that means that that amount is kind of being included twice because it goes into both circles. So if you remember, you would have filled in your Venn diagram in the intersection, and then you would have subtracted that from your outside of your set A and the outside bit of your set B. And this is the same concept. So basically what we're saying here is, for a normal kind of mutually inclusive event, so again where they have an intersection, basically to work out A union B, so again that's to work out everything in both circles, you're going to add probability of A plus probability of B, and you're going to subtract the intersection, because remember the intersection is actually included twice when you're looking at it in that format. And similarly, this formula can also be flipped the other way around. So we can change it to A intersection B. The probability of A intersection B is equals to probability A plus probability B minus the probability of A union B. So all I've done there is I've just swapped the union and the intersection around. Okay, and that's a really, really useful formula to have for probability. The next one then is mutually exclusive events. So these are events that have no outcomes in common. So the main thing you need to remember there is, because they don't have any outcomes in common, therefore they don't have an intersection. So again, I've written here A intersection B, the probability of that is the null set is empty, okay? It's 0, it's your null set. And again, if you're told anything about mutually exclusive events, then you know that this is the case straight away. So again, this is following on from this formula. That the probability of A union B is just probability A plus probability B. And the reason why we don't need to write this bit down is because there is no intersection, so you wouldn't need to minus 0 from that. It would be, not required. Okay, moving on then to our next 2 important things to be aware of in this probability chapter is independent events and conditional probability. So independent events are when the outcome of one event does not impact the outcome of the other. So what we need to be aware of here is that when you're working out the intersection between the probability of A and the probability of B, when they're independent events, that intersection is actually the probability of A multiplied by the probability of B. So, and this has come up in the Leaving Cert before, if you're asked to prove that two events are independent, you need to multiply their probabilities by each other, and that should give you the same answer as the intersection of those two probabilities. And again, we'll look at an exam question on this now in a second, and I'm pretty sure we are asked to prove that, so I'll show you how that works. And then the last one. This one was new to you in your Leaving Cert. You would not have done this in your Junior Cert. So it's conditional probability. So it's if one event does affect the outcome of a second event, then the second outcome is said to be a conditional on the first outcome. So look, the classic example you might remember when you did this in school is you might say, right, you've got students in a class and we're trying to work out the probability of picking a girl given she wears glasses or something like that. So we're putting an extra condition on our probability. So we're saying given she wears glasses. So actually we don't care about anyone else in the class who doesn't wear glasses. Our probability is actually just the girls who wear glasses in the class. So again, when you're working with conditional probability, there's a few like little tricks, I suppose, to remember. So the way I always kind of remember it is that this here means the probability of B given A. Okay, that's how I would read this out loud. So the probability of B given A. And the trick is that you find the intersection of these two on the top, because we're basically saying, right, it's the thing we want and the condition together. And then whatever your condition is always goes on the bottom. So again, if we go back to my example there a minute ago of what's the probability that I pick a girl given they wear glasses. So again, what we're saying is everyone who wears glasses is going to be down here, and then the people that wear glasses and are girls are going to be up here. Okay, so again, we'll look at an example of that now in a second, but I would really recommend again that you do commit that to memory, because if it does come up, you need to know these in order to be able to access these questions. So with that in mind, we're going to have a look at a Leaving Cert higher level probability question, and this is it here. So we're told two events, A and B, such that probability of A is equals to 0.2, probability of A intersection B is equals to 0.15, and the probability of A complement intersection B is equals to 0.6. And part one of this question is we're being asked to complete the Venn diagram. So this is kind of going back to some like junior cycle maths really. So if you remember back in your Junior Cert when you were ever given either the cardinal number of a set or the probability or whatever it was, you needed to remember that that's the entire circle. So you could write it out here. Sometimes I would have taught my students to put it in like the bracket on the outside to say that 0.2 is the entire A circle. So if we want to fill in the outside bit then from the intersection, you're going to do 0.2 minus 0.15 and you get 0.05. Okay, so that goes in there. And then we need to look at this other clue. So we're told the probability of A complement intersection B is equals to 0.6. So again, just to refresh your memory, A complement means everything outside of A. So again, I always say to my students, put your finger or your hand over the A circle. So that's everything outside of A. And its intersection with B. So it's basically where is outside A that's in common with B. And it's obviously just going to be this section here. So they're actually just giving us that answer straight away. We don't need to do anything with it. We just need to put 0.6 in here. Okay. And again, what you need to be careful of is we want to fill out the entire Venn diagram. So what we need to remember is that we have to figure out if there's anything that goes outside into the universal set. So I'm going to add them all together and I'm going to subtract them away from 1. and I'm left with 0.2. So 0.2 goes out there. Okay, so then part B of this question says, find the probability that neither A nor B happens. Okay, so look, this one is obviously very straightforward. We've just worked it out. It's the outside into the universal set, so it's going to just simply be 0.2. So you don't need to even go and do any calculations there. You've got your answer from your Venn diagram. But the next bit, find the conditional probability of A given B. So this is where your knowledge of your formula is so important. So without even thinking about it, this is what needs to come into your head before we actually go and look at the numbers. So you need to remember, okay, so Anu's told us that the conditional probability formula is as follows. You find their intersection on the top of the fraction, and then the given part, which is always the second part, goes down the bottom. Now, once you've got that written out, this question should become very straightforward. So all I have to write down now is, well, what's the probability of the intersection? Well, it's on my diagram already. It's 0.15. And I need to go and work out what the probability is of B. So I need to add together the 0.15 and the 0.6. So that gives me 0.75. So on my calculator then I'm going to do 0.15 divided by 0.75, and that's giving me an answer of 0.2. Okay, and then the final part of this question says, state whether A and B are independent events and justify your answer. Okay, so again, in order to approach this question, you need to know the formula that we spoke about. Now, some of you may know from even looking at the conditional probability part where the kind of answer comes from, but I just want to show it to you in regards to what I spoke to you about a minute ago. So for independent events, if I go back to what we looked at a second ago, we said that the intersection is equals to probability of A multiplied by probability of B. So that's what we're going to do, okay? So we're going to say, right, the probability of A is equals to 0.2, and the probability of B is equals to 0.75. So we're going to multiply them by each other. So we're going to do 0.2 multiplied by 0.75, and we get an answer of 0.15. Now that is equals to the intersection, which is probability A intersection B. So therefore, A and B are independent. Okay, and when they say justify your answer, they basically want you to show why they're independent. So they're saying, so they're asking you to explain to them, well, how do you know they're independent? And we've just done that because we've said, well, if the probability of A is this and the probability of B is this, and I multiply them, I'm getting that answer, which is the same as the intersection, which shows that they're independent events. And again, the way I knew to do that was knowing that formula that we had on the last slide there as well. Okay. And the other way that you could prove it if you wanted to is you could say that the probability of A given B is equals to the probability of A. They're both the same, and that also shows that they're independent as well. So whichever one, again, you've kind of done more practice on, either one would work perfectly there. Okay, the next thing I want to talk to you about then is Bernoulli Trials. So a Bernoulli trial is an experiment in which a single action is repeated over and over. It could be rolling a die or flipping a coin. So it's something that is repeated, as I said. And some of the kind of main things you need to know, again off by heart to do with Bernoulli trials, is that there are only two outcomes, and we sometimes would call them success or failures. You don't have to call them that, but it's just, I suppose, one way of thinking about it. So like the thing happens or it doesn't, or like they score the goal or they don't. Number two is that the probability of each outcome does not change from trial to trial. So again, if you're looking at, let's say, somebody taking penalties, that in the real world, we might say, well, yeah, if you miss a penalty, that might mess with your kind of emotions or your head and you might not score the next one. Or maybe it would make you more, you might lack confidence and you might go for a strategy that you haven't gone for before. There's lots of real life ways that could change your your outcomes or your probabilities. But in this example, when we're using Bernoulli trials, we would say that, yeah, when I take penalties, my chance of scoring is 0.75, and that's always going to be the case. So it does not change when you're taking the first, the second, the third, the fourth. And the third one is that the trials are independent of each other. So again, they don't have any impact on each other. And the formula down the bottom of the slide there is the formula that we can use then when we are working with Bernoulli trials. So basically what it does is we're saying we're going to take the amount of trials and choose how many of them are actually successful. And then we're going to say the probability then of the success raised to how many times we're successful, multiplied by the probability, I'm going to say, of failure. But again, it doesn't necessarily mean failure, but just not what we're looking for. And then we do the n minus or, which is basically just like the other amounts of times that are left over. Okay, now when we do a question, this will make more sense. So let's have a look at an exam question then. So part A of this question, we won't be using Bernoulli trials, but we will use it for part B. So it says, when Connor rings Ciara's house, the probability that Ciara answers the phone is 1/5. So look, without even reading anything more into this question, I suppose straight away we're thinking about the fact that this could be a Bernoulli trial question, because the probability she answers the phone is 1/5. So you could say that's success. And therefore the probability that she doesn't answer the phone is 4/5. And they're not saying it changes or anything like that. It's consistent, they're independent, etc., etc. So let's just keep that in the backs of our minds. So our first part, part A, is saying Connor rings Ciara's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, the 4th, and the 6th days, but not on the other days. So this is very similar to the question that we did at the start, where we're just looking at, let's say, I think it was the boys and girls in the class. You're just going to line them all up and multiply their probabilities by each other. So again, we're saying the probability she answers is 1/5, so the probability she doesn't answer is 4/5. So, so she answers them on the 2nd. So that means she didn't answer it the first day. She answered it the 2nd day. She didn't answer it the 3rd day. She answers the 4th day. She doesn't answer the 5th day. She answers the 6th day, and she doesn't answer on the 7th day. Okay, so literally you're just writing those fractions down. You're multiplying them by each other, and the answer you should get is 256 over 78125. Okay, so that's that one. The next one, find the probability that she will answer the phone for the 4th time on the 7th day. Okay, so this is a Bernoulli trials question. It's a little bit harder than like a standard Bernoulli trials question, but it is one nonetheless. So what we're being told is that she answers the phone for the 4th time on the 7th day. So we definitely know on the 7th day what she did. She answered the phone, okay? So if we kind of imagine, right, let's say we've got our 6 days here, and then we have our 7th day where she answered the phone. So 1/5 would go here. The problem we have in the box here, which represents the 6 days, is that means that, okay, she answered it for the 4th time on the 7th day. That means she answered it 3 times. So she answered 3 times in here. And that means then she didn't answer, so no answer, on 3 times as well. So 3 of the days she answered, 3 of the days she didn't answer. But the problem we have compared to part A of this question is we don't know, was it the first 3 days she answered? Did she answer every 2nd day? Like, we don't have any idea. So this is where Bernoulli trials is going to come in and help us. So even though we're talking about 7 days, because we're being given what she did on the 7th day, we're actually going to do this Bernoulli trial for 6 days. And we're not going to count the 4th time because we've counted the 4th time there. So we're counting 3 times. So we're going to use Bernoulli trials to help us to work out the following. Okay, so we're going to work out how many times the probability that she answered the phone 3 times in the 6 days. Okay, so that means success is that she answers the phone. So the probability of success is 1/5. and the probability, I'm just going to say failure, is 4/5. And we're saying that it's going to be 6 days, and we're choosing the 3 that she answered the phone. Okay, so we're going to set this up then. So it's going to be 6. I should do this in a different color. So we're going to do 6, choose 3. So we're saying it's out at 6 days and she was successful 3 times. Then you write down your probability of success, which is 1/5, and you raise that to how many times you were successful, or she was, which is 3. Okay, so it's always the bottom number, but I always like to think about it more as the thing that you were successful in. Then you're going to multiply that by the probability of failure, which is 4/5, and how many times they failed. Or again, like the formula states, it's 6 minus 3, but that's just obviously the 3 that was left over with the failures. So that's your Bernoulli trial, but you can't forget about this 1/5 up here. Remember, we then need to multiply it by 1/5 for the 7th day. Now look, you could have obviously done those two separately or together, it doesn't matter. So again, remember that that's 6, and the 3 at the very start of this question, that is not a fraction, that is 6, choose 3. I know I taught my class this during the lockdown last year, and what was difficult was trying to, I suppose, explain all this and show that like that's not a fraction, that's actually your choose button. So just that is definitely something to kind of keep an eye on, even going back over your old notes and stuff like that. So I'm after popping all that into my calculator, and I'm after getting an answer of 256 over 15,625. And obviously there's no problem with writing that as a decimal, but it's just going to be a long decimal, so I just prefer to write them as fractions. Okay, so the next thing I want to go on to then, guys, we've done a good bit there on probability. We're going to move on to statistics now. So in statistics, I'm going to talk to you a little bit about scatter plots. I'm not going to go over all the other types of diagrams or the mean, the mode, the median, all that. But again, on our website, examrevision.ie, I do have videos done on all of those things. So do check it out if you think you need any further support with those kind of sections. So just a reminder, scatter plots, scatter diagrams, there's a few different names for them, but they basically are a way of showing 2 different pieces of data and their correlation with each other. So in this particular example, I just actually took a screenshot from one of my videos. You can see we've got students' maths marks and students' science marks, and we're pairing them up with each other. And we're basically trying to see, is there a correlation or is there a connection between the students who maybe do very well in maths? Are they also doing quite well in science? And they are, you can see that. They're relatively speaking, they have similar exam results, and then similarly the students that maybe find maths more difficult, maybe they are finding science more difficult. Now again, that's obviously a really small sample, that would be in no way statistically correct, but it's just a way of representing your data, so your bivariate data. And again, I'm not going to go into this in loads of detail. The video goes through it in a lot more, but just a reminder then about your scatter plots, your scatter diagrams, and this whole idea of correlation. So correlation is looking at the relationship between the 2 pieces of data. And what you might remember when you did this is that we spoke about strong positive correlations, no correlation, negative correlations, etc., etc. And basically all you need to remember is if they're all really, really close together along a straight line, you would say that it's a positive correlation, whether that's a positive one or a negative one. And if they're more spread out, you could say maybe it's a weak positive or a negative correlation. And if they're literally just all over the place, there would be no correlation. The next thing you need to know then is this thing about your correlation coefficient. And your correlation coefficient, is the letter we use to represent it is or, and it's always between -1 and 1. So if you're ever asked to calculate the correlation coefficient, you're basically trying to figure out, instead of just kind of saying, oh, it's quite strong, or it's kind of weak, or there's no correlation, what you can do is you can actually go and work out the exact number. And that exact number, if it's really close to 1, you know that it's a really strong positive correlation. If it's really close to -1, then it's a strong negative correlation. But if it's really close to 0, well then it must be like basically there's no correlation between them at all. And what I wanted to mention in this, because this is definitely a question that we get in at exam revision quite a lot, is how do you work out the correlation coefficient on your calculator? Okay, so what I've done it out for the two different calculators now, just because that's just here to confuse us even more. I know some of you are probably using this calculator here on the left. This is the one you probably had for your junior cert if you still have it, but if you did buy a Casio calculator in the last kind of year to 2 years, year and a half maybe, you're dealing with this new one. Okay, and the easiest way to spot them, they both have pretty much the same code, but the older Casio calculator has the blue buttons on it, and it has natural VPAM written at the top in red, and then the newer Casios don't have the blue buttons, and it says class whiz at the top. So that's basically the steps that you can take. Now look, in isolation those steps might seem a bit bizarre, but if you are asked to work out a correlation coefficient, that's very, very helpful. So again, you're going to get the notes from this afterwards. So it's something I would just say to you to refer back to when you're practicing this. In the video on correlation coefficients, I do go through this in detail, and I actually show you how to use your calculator to do it. I do use the older calculator because that was the one I had when I was making them, but again, I've written out the steps for both types of calculators for you, so I'm not going to go through that now because it does seem a bit abstract. But basically, if I go back to this question here, you could have been asked in the exam, and that this has come up before, right? Here's your frequency diagram. We want you to calculate OR, which is your correlation coefficient, and you would need to be able to go on your calculator and figure that out. So again, those steps there will help you to do that. And if you do want any further help with it, if you do check out the scatter plot video on examrevision.ie, I go through that in loads and loads of detail. Okay, so moving on then, I want to talk to you about our normal distribution. Okay, so we're dealing with this chapter. Again, it depends on what book you use. Some call it the statistics chapter, some call it statistics and probability. But basically, yeah, it's a combination of the two of them really. And this is the one that really comes up, not most frequently, but it does come up frequently on the Leaving Cert higher level paper 2. So it is something that I would definitely recommend that you spend a bit of time on. So again, I'm not going to go into this in loads of detail. The basics I'm taking that you obviously have done. You might just need to refresh your own memories on it. But the normal distribution is basically a way where we can represent things in real life in a lot of instances. So it says here like the heights of people, the size of things produced by machines, errors in measurements, blood pressure, etc., etc. So what we notice is that there is certain things that follow this bell curve shape, which we would say then is normally distributed. And in maths then, that allows us to kind of figure out quite a lot of things, because when data are normally distributed, it means that we can figure out probabilities and we can make assumptions on the data, because we can see here that because of this line of symmetry, that 50% of your data will be to the right of the mean, the mode and the median, and 50% will be to the left hand side. So again, it allows us to work out and predict the proportion of something that will be greater than a particular value, or the percentage of people that will be below this height, etc., etc. So it's something that's really, really useful, and it helps us to calculate quite a lot of things. So following on from that then, and how we need to be able to kind of use it and understand it, is the empirical rule. Okay, now when we're talking about the empirical rule, we're talking about our standard normal distribution. So I might actually go to this for a second before I talk to you about the empirical rule. So your standard normal distribution is where we have anything that's normally distributed that we convert into this standard normal distribution. And the easiest way to think about it is, yeah, I know people's heights are normally distributed, but obviously the mean height of a population is going to go into the center, and then people that are taller will go to the right, and people that are smaller will go to the left. But all those numbers are going to be like random numbers. And then I know that errors in measurement are also normally distributed, but they are distributed in a different fashion. And the issue that we have is, if these are all normally distributed but they're all different numbers, they're quite hard to work with. So what we ended up doing was we ended up coming up with standard units to represent standard normal distribution. And that's where your formula tables come into play. So if you remember, if you've done this in school, if you remember your standard normal distribution, or you remember doing any work on this in school, the pages in your formula tables that you've been working with, they are all the numbers that are associated with your standard normal distribution. And again, if I just go back to our empirical rule then, and this is on the higher and the ordinary level Leaving Cert course, this gives us kind of ways of summarizing the data. So the empirical rule states that if you are within one standard deviation of your mean, that would represent roughly 68% of the population. If we're within 2 standard deviations of the mean, we would say that's about 95%. And if we're within 3 standard deviations, that's about 99.7%. So these are figures that you should commit to memory, and they help us to understand more about our data. So again, you're looking at the standard deviation, how far away you are from your mean, and that allows us to then figure out what proportion or what percentage of your data will fall between those two parameters. Okay, so that's that. So again, I spoke to you briefly there about your formula tables. So that's page 36 and page 37 of your formula table. So it would be great if you could have those open in front of you now for the next couple of minutes when we're talking about this. Again, what I would say to you is a couple of things just to be aware of, and it tells you here in your formula tables. So when we're working out anything to do with your standard normal curve, it always works it out as less than or equals to that. So just be aware that if you're being asked to work out the probability that Z is greater than something, you may remember we're going to have to do a little bit of work on that. So it always works it going back the way, so it's always working out as being less than that number. And the other thing to remember is that your tables only start at 0, 0. So they only start here and go all the way up. So if you also remember, if you've got a minus, you have to be careful, and I'm going to show you a few examples of that as well. Okay, so if we had, let's say, I'm just going to show you 2 kind of basic questions on this. So let's say we're being asked to work out the probability that Z is less than or equals to 1.2. So the number one piece of advice I can give you on anything to do with standard normal distribution is you should always draw yourself a diagram. As you can see from my one, it does not have to be anything fancy, but draw yourself a diagram, because it will really help you to figure out what direction you have to figure it out. Are you shading to the left? Are you shading to the right? And all those other little things in between. So the probability that Z is less than or equals to 1.2. So you're simply going to go and find 1.2 in your formula tables, because this one is nice and easy, because they're asking us to find less than that number. You're going to draw your line and you're going to say, oh yeah, it's everything this way, and that's perfect because that's exactly what my formula tables does. So you're going to go and find 1.2 and you get your answer of 0.8849, which is this answer here. Now, let's say you were also asked, and you can see this underneath here, you were asked to work out the probability that Z is greater than or equals to 1.2. So if that came up in the exam, what you'd need to have done is you would have drawn your diagram. You would have gone to 1.2, you would have drawn your line, but because it was greater than, you would have said, okay, I'm trying to work out everything to the right-hand side of that line. But my formula tables doesn't do that for me. It only works it out to the left-hand side. But then you need to think that we know that the area underneath our standard normal curve always adds up to 1, because probabilities add up to 1. So we can do 1 minus the probability of Z being less than or equals to 1.2, and it gives me the same answer. So again, we did 1 minus 0.8849, and you get your final answer that way. So again, essential to draw yourself a diagram. If we look at one more example of this then, let's say we're being asked to work out the probability that Z is greater than or equals to minus 2.13. So the easiest way to kind of imagine this is to say to yourself, okay, I'm going to draw my diagram and I'm trying to work out minus 1.23. So it's going to be down here somewhere. And we're trying to work out all of this. So I've got two issues here. The first issue is that it's down in the negative part, which we're thinking that doesn't really work. And then the second thing we're thinking is, okay, hang on a second, it's also going to the right hand side, and we've learned that we can only go to the left hand side when we're using our standard normal distribution. So the first thing you need to do is create a mirror image for yourself, because this is symmetrical. If I go, and I know my diagrams are not symmetrical, but you get the idea. If I go across to 2.13 and I shade this side, that is the exact same area as that one. So we've basically figured out, well, if I work out this one, if I work out the probability of z being less than or equals to 2.13, I'm actually going to get the same answer. So you're going to go to 2.13 and you get your answer of 0.9834. Now, sometimes students say to me, oh, Anya, do I need to go and like put a minus in front of that now or something? No, absolutely not, because area is obviously positive. Like, think about it, you're finding the area underneath the curve. So all of these probabilities that you're working here are all positive numbers. The only ones that are ever going to be negative will be your z scores when you go to the left-hand side of your graph. Okay, so that's that. The next thing I need to talk to you about then is sometimes we have to convert into these lovely z scores. So in the last two examples, we were given the z score straight away. So we were asked to work out z being greater than this, being less than this. Sometimes you won't be given z though. Sometimes you will have to go and work out what z is. And this is the formula that you need to use. So if you're given a question where they ask you to calculate the probability of something happening, and again I'm going to show you this in a second in an exam question, but they're talking about like the mean weight was 34 kg and the standard deviation was this, that and the other, that basically means that we have to go and make that into a z score before we actually use our formula tables. So if you go to page 34 of your formula tables, you will see this formula kind of in the middle of the page. It's called the standardizing formula. So it's z is equals to x minus mu over sigma. So basically what that means is we're going to take whatever your thing is that we're trying to work out the value of, the probability of, and you're going to minus away your mean and you're going to divide by your standard deviation, and that will give you the z score for that particular question. Okay, so let's go and actually put that into some use then. So if we look at this example then really quickly. So we're told that a normal distribution has a mean of 1010 and a standard deviation of 20. And we're being asked to work out what is the probability that a sample chosen at random will have a result larger than 1040. So basically we're being asked to work out the probability that x is greater than or equals to 1040. But the issue is we don't have anything that can help us calculate that. We only have z scores. So we need to convert 1040 into a z score. So what we're going to do is and it's all done for you here, we're going to say, right, that's the same as 1040 minus the mean, which is mu, which is 1010, divided by sigma, which is our standard deviation, which is 20. And that gives us 1.5. So again, what you're going to do then at that stage is you're going to say, okay, so now I'm trying to work out the probability that z is greater than or equals to 1.5. You're going to go and draw yourself your diagram. And what you're going to notice is that when you fill in the probability of it being greater than 1.5, it's going to be the wrong side of your line that's shaded. So you actually have to do 1 minus the probability of being less than 1.5. And when you go and do that, so you go and get your 1.5, so that's going to give you 0.9332, but you need to find the opposite side of it, so you're going to do 1 minus that, and you get your answer there as 0.0668. Okay, so again, that's just looking at the right and the left-hand side of your lines. Okay, right, we're going to do one or two very quick questions on this, and then I'm going to go on to talk to you about hypothesis testing and 95% confidence intervals and things like that. So in this question, we're told the diagram shows the standard normal curve. The shaded area represents 67% of the data. Find the value of Z1. So I really liked this question when it came up because it kind of got students thinking about what, your Z score represents and what your probabilities represent. So they're telling you that this entire section here is 67%. Now, we know we're not actually used to using percentages when we're using our formula tables. It just gives it to us as a decimal. So the first thing I'd be doing is I'd be saying, okay, well, 67% is the same as 0.67. So if I know what the probability is, how could I possibly work out the z-score? So what you're going to do is you're going to go to your formula tables, and you're going to go to like the inside bit of your formula tables, and you're going to keep going along until you see 0.67. And if we're really lucky, there might be 00 at the end, but sometimes you'll see that there's like 0.6703 or something, and you'll just pick that. It's whatever is the closest to 0.67. But in this question, they've been really nice because 0.6700 is there. And if you go across the left and up to the top, you'll see that that matches with a z-score of 0.44. And that's your answer for that one. So basically all you had to do in that question was take the probability and find the matching z-score to it. Okay, next question. So this is where we're going to use our standardizing formula. So it says the percentage results in a maths exam for a class had a mean of 70 with a standard deviation of 15. The percentage results in an English exam for the same class had a mean of 72 and a standard deviation of 10. The results in both exams were normally distributed. Okay, so straight away we're seeing that word normally distributed. We're thinking, right, we're probably going to have to use one of those pieces of information in a minute. So we're told that Mary got 65 in maths. So in maths she got 65 and in English she got 68. In which exam did Mary do better relative to other students in the class? So this is where, remember we were told this was normally distributed. So if we can work out where her result lies in relation to the rest of the class on our bell curve, we should be able to figure out which one she did better in. So what we need to do first of all is you need to get your standardizing formula, which again you find on page 34, and we're going to work out our z-score. So I'm doing the maths one first. So z is equals to, so remember it's x minus mu over sigma. So it's 65 minus the mean for maths, which is 70, over the standard deviation, which is 15. So that's going to give me minus a third. And then I'm going to do the same for English. So it's going to be 68 minus 72 all over 10. And that gives me minus 2/5. Now, at this stage, what I know probably a lot of students would have done in this exam was they might have gone and drawn this for themselves. So minus 1/3. And then this one is minus 2/5. So again, when you're trying to think about this, even if you wanted to change it into decimals, it might help. But this one is going to be like slightly further to the left. So because the minus 2/5 is slightly more to the left, it means that she must have done better in maths. Because if you think about it, if we put this onto the same diagram, the minus, now that's obviously way off, but like in there. So her English score, which is the blue line, is obviously further to the left, which means that's further away from like the average and the mean and how much better she did. So it means that the red line represents the better score, which is obviously maths. So the class she did better in was maths, and the reason is because minus 1/3 is obviously greater than minus 2/5. You could explain that in more words verbally as well, but that's the idea there. Okay, so moving on then, guys, we're going to talk, I'm just conscious of time, I want to keep going on this. We're going to talk about sampling distributions and your 95% confidence interval and hypothesis testing. So first of all, just to understand, and I think this is really, really important when we're dealing with statistics, so sampling distributions. So what you need to realize is that we know when we carry out investigations, we do have to sample at times. We don't always use the whole population. And what we need to be aware of is that we have kind of two different sampling distributions that we are concerned with in the Leave and Cert course. And the two of them are, we've got our sampling distributions of the sample proportion, and we've sampling distributions of the sampling mean. Now, if I can give you one piece of advice on inferential statistics that you could take away from today, is that every time you do a question that's to do with a 95% confidence interval or to do with a hypothesis test, you need to figure out which one of these is which before you start the question. And I can guarantee you, if you'd make that small little change to how you're doing these questions, it's going to start making more sense why we're using particular formulae over others. For me, even when I started teaching this, when I started going to some of the project maths workshops a number of years ago, that was one of the things that like I really took away, that I had to figure out which one was which in my head. Otherwise, I was getting confused between which formula worked in each question. So again, we're talking about the proportion, and we're talking about the mean. And each time we do one of these questions now, I want you to keep that in mind. So we're going to start off with the proportion, okay? So we're going to think about the sample and the population proportion. So it says the distributions of all sample proportions, so again, we're talking about the proportion one to start off with, for samples of the same size and sampled under the same conditions will have the following properties. So look, they'll be normally distributed, which is really important for what we're talking about now. The mean of the sample proportion will be equals to P, the population of the proportion. And the standard deviation, called the standard error of the proportion, is given by this formula. So if you have your formula tables open in front of you, I'd like you to go to page 34. And if you look down the bottom of page 34, you'll see that there's a thing called sampling. And you don't need to really worry about the first one. It's the bottom two that you need to worry about. So it's the standard error of the mean and the standard error of the proportion. So it's the proportion one that I want to talk to you about now. So again, that's that decision you need to make in these questions. Is it a proportion question or it is a mean question? So in this one, we're talking about the proportion. And it says if P is unknown, we use P hat instead. And that's also important because in a lot of the questions, you won't know P, so you'll use P hat instead. And again, I will show you that in the next part of this, and it will make more sense. So that brings me on to then the 95% confidence interval for the population proportion. So in the exam, if you're asked to come up with a 95% confidence interval, again, you need to say to yourself, is it for the population proportion or is it for the population mean? And if it's for the population proportion, this is the formula that you need to know off by heart. Now, you don't need to learn every single bit of it off by heart. You'll see that this thing here and this here is the standard error of the proportions. This you'll find on page 34. The only difference is instead of it being P hat, like I have it here, it's P. But as I just mentioned on the last slide, if you don't know what P is, you use P hat. And again, I'll show you what P hat is now in a second. So basically what you're doing is you're trying to work out P, which remember is the proportion of the population. So what you're trying to do then is you're saying, right, I'm going to work it out for my sample minus 1.96 multiplied by your standard error of the proportion formula. And then on the other side, it's your sample proportion plus 1.96. And the reason why we're using minus 1.96 and 1.96 is because it's a 95% confidence interval. So they are the Z scores that go with 95%. So again, you need to learn this off by heart. Let me show you how this comes up in a question then. So it says, a motoring magazine collected data on cars on a particular stretch of road. Certain details on 800 cars were recorded. The ages of the 800 cars were recorded. 174 of them were new. Find the 95% confidence interval for the proportion of new cars on this road. Give your answer correct to 4 significant figures. So again, you're in your Leaving Cert, you're looking at this question, you're thinking, right, it's a 95% confidence interval question. It's something to do with minus 1.96 and 1.96 multiplied by the standard error. However, I need to figure out whether this is a proportion question or a mean question. The easiest way to figure out that it's a proportion question is that you're basically working out like a fraction. It's the proportion of this over this. So it's the portion of these 174 new cars out of the 800 cars. That's the easiest way that I remember it. So the first thing that you're going to do is you're going to go and work out what your P hat is. And that's your sample proportion. So that's going to be your 174 out of your 800 cars. Now, I always kind of go to my calculator now and just figure out, is that going to give me like a nicer answer? It doesn't really when I put it into my calculator. It doesn't simplify down. Sorry, let me just clear my calculator here. So it's going to give me kind of like a long decimal. But it does simplify down slightly to a nicer fraction. So I might just write it as a nicer fraction. But again, if you wanted to write it as a decimal and you're more comfortable with the decimals, that's fine too. So that's your sample proportion. So in your head now, you've figured out I'm doing a 95% confidence interval for the proportion of cars. So I'm going to use the sample layer of the proportion. So now you need to set up your 95% confidence interval. So P is in the middle, because remember that's the thing that you're kind of working out your interval for. And you're going between the following, okay? So we're saying it's going to be P hat. I'll actually just set it up like this first of all. So it's P hat minus 1.96, and you go to your formula tables and you write down your standard error of the proportion formula. Remember it's P hat because we don't have P. And then it's P hat plus 1.96 multiplied by P hat 1 minus P hat all over N. Right, so that is going to give me 87 over 400 minus 1.96, and then you're just writing those in here. So 87 over 400 bracket 1 minus 87 over 400 all over N. And remember, N is the amount of like the sample that you took, so it was 800. Now, I'm not going to write this all out again, but you're basically going to write that exact same thing here, except there's going to be a plus in the middle instead of a minus. And you're going to literally put all of the left-hand side into your calculator and all of your right-hand side into your calculator, and you're going to get 0.1889 and 0.2461. So we're saying that based on your sample proportion, that P is going to be between those two at a 95% confidence interval. Okay. Moving on then to our sample mean. So again, this was the other one we said. So if we're being asked to work out a 95% confidence interval, we may be asked to do it for the proportion, or it could be for the mean. So the mean is the other one. So look, this you can read through this in your own time afterwards, but it's just to note that when you work out the mean of a sample, we call it X bar. Okay, whereas when we work out the mean of the population, we say it's mu. So that's just a kind of a side note to be aware of. Then the important thing when we're talking about the sample means is that we have this thing called the central limit theorem, and that it states no matter what the distribution of the population looks like, the distribution of the sample means collected from the population will be normally distributed. So again, that's why we're able to use our whole normal distribution in these questions. Again, most important thing to be aware of is that when you're dealing with sample means now, we won't be using the P hat formula anymore. We're going to be using the formula that's the second up from the bottom, which is the standard error of the mean. So this is your standard error of the mean formula. Again, it's on page 34. And just a little side note, if the standard deviation of the population is not known, then we can use the standard deviation of the sample, which we call S instead of sigma. Now, I'm not going to show you an example of this. I'm just going to give you the formula, but we will go on and do a hypothesis test now in a second where I'll show you where this comes into play. So for the 95% confidence interval for the mean, the population mean, we're saying mu is going to be between. So X bar, remember, is your sample mean. So it's your sample mean. Again, it's the same. Then next bit, it's minus 1.96 by the standard error. But again, instead of using it for the proportion, we're using it for the mean, and then it's plus on the other side. Okay, next thing I want to talk to you about is hypothesis testing. So hypothesis testing is a statistical test that is used to determine if there is enough evidence in a sample of data to draw conclusions that a condition is true for the whole population. When we were asked to run a hypothesis test, you need to remember that we have two things that we need to write down straight away. We've got our null hypothesis and our alternative hypothesis, sometimes called H0 and H1. So again, H0 is the claim that we initially assumed to be true, and then H1 is the one that we initially assumed to be false, but we may accept it if we reject the null hypothesis. So when we're asked to carry out a hypothesis test, you go back to the same two questions again. Is it the population proportion or is it the population mean? And again, that's important because it's going to dictate how you're going to do it. Your 95% confidence intervals are going to help us here loads as well. So if you're being asked to carry out a hypothesis test for the population proportion, so we're going back to the first one that we looked at. Step 1 is that we establish the hypotheses. So you write down your null and your alternative hypothesis. Step 2 is you find the value of the test statistics p-hat. So remember we did that in the last example. So it was like 174 out of the 800 cars. That's your p-hat. And when you're asked to carry out a hypothesis test, generally they say that we're running it at a 5% level of significance. And that basically means that we want to work out, they're the critical values, let's say, on each side. They're your 5% or your 2.5 on each side. So that means that we actually can just go and calculate our 95% confidence interval, like we just did in the example that I did a few minutes ago. And you look at the set of values that your null hypothesis must lie in. And if your null hypothesis is found within those values, then you can say that we fail to reject the null hypothesis. But if it's outside those values, then we would say we reject the null hypothesis. And again, I'm not going to do a full example on that because I want to do an example of our population mean because I didn't do that for your confidence interval, but do look at ExamRevision.ie. There's all these done out in videos if you need more examples. So now we're going to look at it for the population mean. So again, the same step 1. We establish the null and the alternative hypothesis. Step 2. Now there's 2 different ways of doing this, right? This is like one way that you can approach this question. So you go and you work out your test statistic, which is your sample mean, and you convert it to z-scores. So we've already looked at converting to z-scores. You go and do that. You then think about your 5% level of significance and the fact that that means that we have here and here, that these are basically the areas that we want to reject. So I know that that's minus 1.96 and that's 1.96. So if you get a z-score that's smaller than minus 1.96 or greater than 1.96, they're going to fall out here, which means that you would reject your null hypothesis. But if it's found anywhere in here, you're going to accept it because it's within your confidence interval. Now, you could also, let me just go back here, you could also go and actually work out your 95% confidence interval and do it the same way as I spoke about for the population proportion. That will work as well. So I'm just conscious of time here, so I might just skip on to the last bit of this question. So it said, in 2016, 150 of the 15-year-olds in that country were randomly selected and their weights recorded. It was found that their weights were normally distributed by a mean weight of 62 kg and a standard deviation of 10 kg. Test the hypothesis at the 5% level of significance that the mean weight of 15-year-olds in that country had not changed from 2015 to 2016. And state the null hypothesis and your alternative hypothesis. Give your conclusion in the context of the question. Okay, so I am obviously skipping over this a little bit, but I just want to go back really quickly just to say that we were dealing with 2015 in the original question. So they weren't talking about 2015 being a sample. They were saying that the mean weight was that 63.5, which means that your mu was 63.5, and that sigma, because that's your standard deviation for the population, was 10, because I will need that in the next part of this question. But now we're talking about 2016 and we're talking about the sample. Now, I think this question is very obvious that it's a sample mean question. So it's not the proportion, it's the sample mean. Think about we're talking about the means and the standard deviations. So what we're going to do in this question then to start off with is we're going to state our null and our alternative hypothesis. So H0 is that the mean weight has not changed. So remember, originally the mean weight was, what was it now? Let me go back. Oh yeah, 63.5. And then your alternative hypothesis is that the mean weight has changed. And that's basically what we're going to be trying to prove or disprove by the end. Now, as I said to you, when you're doing a hypothesis test, you've got, for the population mean, you got two options. You can do your confidence interval or you can use your z-scores. It will work either way. So I'm going to do the z-score for this one. But again, either way will work perfectly. So what we need to do next then, our step 2, is we need to use our z-scores to convert our sample mean, which is 62, into a z-score. So we're going to do, so remember z is equals to x minus mu over sigma. Okay, so that's, oh, I'm sorry, that's my bad now. I need to go back for a second because it's going to be your sigma over your root n. So I just want to go back to show you that really quickly because I think I forgot this slide. Yeah, so it's going to be sigma, excuse me, over root n. So the other thing that you need to remember when you're working out your z-score for your hypothesis testing is we have to use your one sample z-test. So when you're working out your z-score, you have to do your mean, your sample mean minus your mu all over. And the bottom bit here is how you're basically going to work out your sample z-test. So here is the same formula that we would have used for your standard error of your mean. So you just need to remember when we're doing your hypothesis test and you're calculating your z-score that we need to use that formula, which is on the top of page 35. So again, you're going to have your x bar minus your mu all over sigma over root n. So that is going to give us 62 minus your original population mean, which is 63.5, all over 10 over the amount of your sample, which is 150. So you're going to go and pop that into your calculator and you get minus 1.8371. Now, if you think about that again, remember it's a 5% level of significance, which means it's going to be between minus 1.96 and 1.96. So what you do at this stage then is you look at this number and you see where it lies. So we can see that it's in here somewhere. So because it falls within your 95% confidence interval, that means that we fail to reject the null hypothesis. So that means that the mean weight has not changed. And we fail to reject the null hypothesis. Okay, now if you wanted to do this the other way, I'm just going to go on to the marking scheme here. I think I have it, yeah. So this is the way that I did it there on the screen. But the other way you could have done it is you could have used your confidence interval. So you could have actually gone and formed your confidence interval. And again, I would have done an example like that with your population proportion. But obviously we're using the mean one here. You could have worked out your confidence interval and you could have seen then that 63.5 does just about fall between those two intervals, so therefore the same conclusion comes about as well. Okay, so for the last half hour, guys, I'm going to move on to talk to you about the line and the circle. I'm sure most Leaving Cert students, like particularly 6th-year students, will have done this at this stage in the year. So this is really just going back over as a quick recap of some of the kind of key parts that you should be aware of. As always, your formula tables are so important, so you should have page 18 and page 19 open whenever you are doing a question on the line or the circle. And yeah, I'm going to just talk you through some of these formulae to begin with. So for the line, again, a lot of this stuff you would have done in your junior cert, and really when it comes up on the Leaving Cert, it's more of an applications question or getting you to, I suppose, work backwards using your formulae and things like that. So the first thing just to remember is that in your equation for the line, in Leaving Cert, we do a lot of the time leave it in that form 1. So just if you see it written like that, just remember it just means it's your equation of a line formula where you've just brought everything over to the left-hand side. And form 2, we would have used a lot in our junior cert, and when it's in the form y equals to mx plus c, remember we can say that m is your slope and c is your y-intercept. And when it's in this form, remember there is a quick way of working out the slope. It's minus a over b. So that's a quick way that you can read the slope from that line. If you're ever trying to work out where your equation of a line or indeed the circle crosses the x or y axis, just let the opposite letter equals to 0. So let x equals to 0 to find where it crosses the y, let y equals to 0 to find where it crosses the x. The next then we're going on to the kind of leave insert formulae. So I'm not going through all of the, the midpoint and the slope and all that, but these are the leave insert ones that you need to know. So the first one I want to talk to you about is your perpendicular distance from a point to a line formula. Now, what you really need to remember is the perpendicular distance from a point to a line is always the shortest distance. So sometimes you might be asked to work out the shortest possible distance. They might not use the word perpendicular, but you need to know that that is the shortest distance. And sometimes they won't use anything to do with perpendicular at all or shortest. But if you're given a point and a line, or you know the distance between a point and a line, this is the formula that you need to be using. Okay, the next one then is your area of a triangle formula, and I suppose the main thing that you need to remember about this formula, it's on the bottom of page 18, or the second from the bottom on page 18, is that one of your vertices must be 0, 0. So if they're not all different vertices, the trick is that you translate them to make one of them into 0, 0, and you just move the other two coordinates by the same amount. Moving on then, we've got your angles between two lines formula. So basically all you need for this one, if you're ever asked to work out the angle between two lines, you just need to know their slopes. So work out the slope of M1 and M2, or line 1 and line 2, I should say, pop it into your formula, but just remember at the end, whatever answer you get here, you have to do tan inverse to both sides to get your final answer. And then the next one is dividing a line segment in a given ratio. So again, it's a pretty straightforward formula. Just remember that when you're setting it up, make sure your first number in your ratio is obviously A and your second one is B. Okay, so we're going to have a look at a quick question then to kind of maybe put some of those things into play here. So we're told that the line P makes an intercept on the x-axis at A0 and on the y-axis at 0b, where A and B are not equals to 0. Show that the equation of P can be written as follows. So this is a prime example of a question where you're kind of looking at it and you're probably not 100% sure where it's going to go, or what to do or where to go. But I suppose the easiest thing you need to say is we're being asked to come up with the equation of the line. So there's two things that we need for the equation of a line. We need the slope and we need either the y-intercept or just a random point on the line. Okay, so the first thing I would do in this question is I'd be working out what my slope is. So if we start off with just writing down our two coordinates, and we're saying, okay, so it's y2 minus y1 over x2 minus x1. So I'm going to label these. So we've got b minus 0 over 0 minus a. So that's going to give me minus b over a. So that's the first bit done. And the next thing you're kind of thinking is, okay, so that's my y-intercept. So I need to think about, well, what's my y-intercept going to be? And again, there's lots of different ways you can go about this. You could work out what the y-intercept is, or you could, if you wanted to, just pick a random point and use your y minus y1 formula. Again, it's up to you, whatever way you want to do it. But it's quite obvious, I think, here, obviously, that your y-intercept is b. So if you did y equals mx plus c, you're going to say y is equals to minus b over a, x, remember? And then because we're dealing with the y-intercept being b, I can just say plus b. So it's y is equals to minus b over a, x plus b. Now, that doesn't look exactly the way I want it to look right now. Okay, so what we might do is we know we want to, let's say, have it that it's x over divided by a, and we want y to be divided by b. So what you might want to do first of all is maybe get rid of the a for a second. So if we multiply everything by a, so if we do ay equals minus bx plus ab, and if I just bring everything over here, so if I say bx plus ay is equals to ab, and then if we divide across by AB, what you're going to notice is you're going to be left with A, oops, actually, sorry, we'll just divide everything by AB, because I know I want the right hand side to be 1, and then they're going to cancel, so I'm going to be left with x over A plus y over B is equals to 1, and we get our final answer there. So the reason I wanted to show you that one is because it's kind of one of those strange questions where, like, yeah, the maths in it isn't that difficult, but the kind of messing around with it to start off with can be a little bit challenging. Now, another way you could have done that, as I said, was you could have just had 0b as a random point on your line and used your y minus y1 formula, and that would work perfectly also. The next bit, it says the line L has a slope m and contains the point 6, 0. Write the equation of the line L in terms of m. Now, I think this is a brilliant question as well, because it gets you thinking about the fact that sometimes you don't need to know the slope and you can still form the equation of a line in terms of m. So you're going to use your y minus y1 formula here. So x1 and y1, so it's going to be y minus 0 is equals to m bracket x minus 6. So it's going to give me y is equals to mx minus 6m. Now, it doesn't tell you what way to leave your question, but you might want to, let's say, bring everything over to the left-hand side, or you might want to just leave it as it is in the form y equals to mx plus c. It really doesn't make any difference, but that's your answer there. You've found the equation of a line, and it's just in terms of m. Okay, now I'm not going to have time to do the next question, but again, the solution is going to be there. But it just says the line L cuts the line this at P, find the coordinates of P in terms of M. So again, they're telling you here, when you see this written in terms of M, it means that, yeah, your answer is going to have M in it, and that's okay. Now, just to recap, to find the point of intersection, or where two lines cut each other, you're going to use your simultaneous equations, which we would have gone through in our masterclass on Monday. So substitution will probably be the easiest one to do for this one. As I said, I'm not going to do it out now, but if you look to the next slide, I've got the solution there that will talk you through what you need to do. Okay, moving on to the circle then. So the circle is relatively new to most of us for the Leaving Cert. For your Junior Cert, you would have dealt with circles where they had centre 0, 0. So the most basic form of a circle that has centre 0, 0 is x squared plus y squared is equals to r squared. So that would be where you've got your centre 0, 0. But then in Leaving Cert, we obviously go on and look at this in a lot more detail. So we have two kind of important things that we need to be aware of. And again, if you look to the kind of second section on page 19, you will see that we've got two different formulas to represent our equation of a circle. So your first equation of a circle is the one I have here, x minus h squared plus y minus k squared equals to r squared. So this is really closely related to what we would have had in our Junior Cert. The only difference is we have two things kind of inside the bracket beside the x and the y. So all you need to remember when you're reading the centre from this form of the equation of a circle is that whatever those two numbers are that are beside your x and the y, you change their sign when they're coming out. And I'll show you an example of that in a second. And then the radius is literally just going to be whatever this number is at the end. If it's not to the power of 2, you need to square root it to get it into its radius form. And then the other version of your equation of a circle is the one that we use a lot when we're problem solving with circles, is x squared plus y squared plus 2gx plus 2fy plus c equals to 0. And again, on page 19, you'll see that that's the kind of second formula, and it's over on the kind of right hand side above the word centre and radius. And the trick that you need to remember for when you're reading the centre and the radius, or particularly the centre, is whatever is in front of the x value, you basically divide it by minus 2, and whatever is in front of the y value, you divide that by minus 2. And that will give you your centres. And then your radius is a little bit more obvious then. Once you have your centre, you're going to square both those numbers from your centre, and you're going to minus away your c. So if we look at that in an actual question then, these are both taken from Leaving Cert papers. So it says two circles, S and C, touch internally at B. The equation of the circle for S is as follows. Write down the centre and write down the radius. So really simple, like you couldn't have it any simpler really. You're being asked to just write down your centre. So I suppose what needs to pop into your head then is that this is the first type of the equation of a circle. This one is the nice straightforward one. It tells you this in your formula tables, but sometimes people get confused with the h and the k. But all you need to do is write down both the numbers, but change their signs. So the center for that circle is 1 minus 6. And then you want to work out the radius. So it's going to be the square root of 360. And again, the reason why we're rooting it is because it's not to the power of 2. So remember, it's r squared. So the square root of 360 is 6 root 10. And I'm not going to do the next part of that question because it's not relevant to what we're looking at now. And then moving on then to the other form of your equation of a circle, you're being asked to find the center and radius. So again, this is the other form. So straight away you need to think, okay, this is the one where we take the x value and we divide it by minus 2. So you're going to do 2 divided by minus 2, which gives you minus 1. And you take the y value and divide it by minus 2, and that gives you 2. So the center is equals to minus 1, 2. And then the radius. So the radius is, and I would always write this down, it's g squared plus f squared minus c. So that is going to give you your answer of 1 squared plus 2 squared minus 20. And that's going to give me an answer of, 25, which is 5. So the radius of that circle is 5. Okay, so we've got 15 minutes left. What I plan to do in the next 15 minutes is just run through some kind of some of the circle problem solving things and just a few hints and tips that should help you when you are working with the circle. So first things first, if you're ever told to prove or show that a point is in, outside, or on a circle, this is what you need to remember. So this kind of is derived from your distance formula. So obviously if a point is inside a circle, it's in here, or let's change the color. What you need to basically remember is that the distance between the center and this point will obviously be less than your radius. So you should have done this in school, where basically you looked at the distance between the points and your center, and then you linked this with the equation of a circle. And basically what you found was that if you substitute in your values, it's going to help you to figure out the distance between them. So basically you take your value and you take the center of your circle and you work out whether that is less than or greater than your radius squared. So it's your distance formula basically. The same with it being outside your circle, and then if it's on the circle, it's going to be equals. The distance is obviously going to be equals to each other. Okay, so if you look at this question here, then just to show you how this would work, we're being told that the point is on the circle and you're being asked to find two values of k. Okay, so what makes this question a bit easier to follow actually is that they've given you the equation and they already, let's say, have squared the radius. So just keep that in mind. The radius has already been squared there, so it's just 65. So because it's on the circle, we can just say, okay, so if we substitute those two values in then, so it's minus 2 and k, so it's going to be minus 2 squared plus k minus 3 squared, and that should equals to 65. Okay, and because they've told us it's on the circle, you're just being asked to find the two values of k, so you simply multiply this all out and you get your two answers of k. Okay, so I'm not going to go and do that, but again, the solution is there for you as well. Okay, the next thing you need to know is about circles that are touching internally or externally. So if you have two circles that are touching externally, that just means that you've got two circles, one outside the other. And what you're going to realize is that the distance between their two centers, so this is center 1 and center 2, like that. Remember, this sign here means the distance. So the distance between them is the exact same as if we were to take the first radius and add it to the second radius. So again, that's a really important thing. If you're ever told two circles touch externally, that should pop into your head. And then if you are told that two circles touch internally, that means that they touch at one point within the circle. So again, if you work out their centers, and if you work out the distance between them, so again, the distance between C1 and C2, that would be the same as taking the radius of the large circle and minusing away the radius of the smaller circle. and that would obviously give you the distance between them there. Okay, so that's your touching circles. The next one is if you're being asked to work out the intersection of a line and a circle. So it's just to recap, I suppose, first of all, when two things intersect each other, the way that we said we find their point of intersection is we do simultaneous equations, and that hasn't changed. Okay, so all the stuff we spoke about in Monday's class is the same here. And it's just to remember that if you've got a circle, that's your linear and your non-linear simultaneous equation. So again, I'm not going to go through this, but it's just to remind you that if you're being asked to work out where they intersect, so they're telling us here that this line intersects at A and B, you're going to use your linear and non-linear simultaneous equations. So that's basically where you take your linear one and you get one of the letters by itself. So let's say I get x by itself, so it's going to be 10 minus y. And then you sub that into your non-linear and you get your two answers. And the two answers you can see here on our diagram are going to be where they obviously cross over. So it's going to be 10, 0, and 2, 8. Okay, the next one. Now again, this is an important one for your problem solving with circles. If you are told that your circle has a tangent or touches the x or the y axis, these are things that you should know to help you with the question. So it says if a circle touches the x-axis, then g squared is equals to c. So I don't have time to go into the the proof of this or to show you where it comes from, but it all comes from the relationship between the radius and the distance between the point and the center. So if you are told that you've got a circle and that it has the x-axis as a tangent to the circle, you can write down straight away on your paper g squared equals to c. Similarly, if you're told that it has the y-axis, you're going to say f squared is equals to c. And if you're told that it has the x and the y-axis as tangents, or that it's touching both of them, you can say g squared equals to f squared equals to c. So if I show you this quick example, then it says the y-axis is a tangent to the circle. Find the equations of the circles that pass through this point, and have the y-axis as a tangent. So straight away, when I'm told that the y-axis is a tangent, what I need to be able to do without any kind of I suppose you can go and work it out by proving it if you needed to, but you need to write down f squared equals to c. Okay, now the way I kind of remember it is I remember that f is associated with my y value. That's not a mathsy way of remembering it, but that's just something that does kind of come into my head to help me. But the proof is done out in a video on our website, ExamRevision.ie. Now, this brings me on then to another part of problem solving with circles, and this is kind of the last kind of big thing I want to talk to you about today. It's when you'll sometimes see it written as problem solving with G, F, and C. So it's basically where you're being given 3 clues to do with the circle, and you're being asked to then work out the equation of a circle. So the easiest kind of version of this is when they give us a point on the circle. So they've actually given us 2 points on the circle here. So what you need to basically remember is when you're doing problem solving with G, F, and C, you are probably going to form like 3 equations with 3 unknowns, and then you're going to, solve them simultaneously to figure out the answers. So this is your problem solving version that we need to use. So whenever you have, let's say, there's another exam question I want to show you quickly where you're just given 3 points on the circle. They don't say anything necessarily about x squared plus y squared plus 2gx plus 2fy plus c. You need to write that down. So whenever you're doing problem solving, that's the formula that's most useful. So what you're going to do to start off with then, I'm not going to do this whole question out, but just to show you, you're going to substitute in 8 and minus 1 to begin with for x and y. So that's going to end up giving you 8 squared plus minus 1 squared plus 2g times 8 plus 2f times y plus c equals to 0. So that's going to give me 16g minus 2f plus c, and I'm just going to bring, that gives you 65. I'm just going to bring that over to the other side, so minus 65. So that's your first equation. Then you go and do the exact same thing for your other number, or your other coordinate I should say, which is 4, 3. So it's going to be 4 squared plus 3 squared plus 2g times 4 plus 2f times 3 plus c equals to 0. So that's going to give me 8g plus 6f plus c. That's going to give me 16 plus 9, so that's 25, so that's going to go over and give me minus 25. Now, I have two equations there, but three unknowns. But then look, this is my third equation. F squared equals to c. So then at that point, what you can say is, okay, why don't I look up to my, so this is obviously in terms of f and c. So if I can get rid of g here, then I can go and like work out further answers for this question. So what you're going to do next then is you're going to take those two simultaneous equations and you're going to get rid of the g. So I'm going to write the 16g down as normal. And again, I'm not going to go through the dynamics of a simultaneous because we did this yesterday or on Monday, but I'm just going to multiply everything here by minus 2 because I want to get rid of the g. It's going to give me minus 16g minus 12f minus c is equals to, oh no, sorry, multiplying it by minus 2. So that's going to be plus 2c is equals to 50. That's going to give me minus 14f was that, oh no, sorry, that was plus c, wasn't it? It's going to be minus 2. So that's going to give me minus c, and that's equals to minus 15. So now I have this formula that has two unknowns, and I've got two equations with those two unknowns, because look, I also had c is equals to f squared. So why don't I go then and substitute in f squared? So I have minus 14f minus f squared is equals to minus 15. So if I change these all to positives, so it's going to be f squared plus 14f. The 15 minus 15 will come over and be plus, but then it's going to change to a minus. And then you're going to go and you're going to factorize this, and to get your two values of f. Okay, so that's going to give me plus 15 and minus 1. So that means that f is going to be equals to minus 15 and f is going to be equals to 1. Now, therefore, I've worked out what f is, so then I can work out what c is, because remember, c is f squared. So 15 by 15, so that's 225. And c is going to be equals to 1. And now all I need to do is go and work out what g is. And you can go back up to one of your original equations. So let's say you go back up to this top one here. So it's going to be 16g minus 2 times minus 15 plus 225 is equals to minus 65. And you end up getting that g is equals to, I think, minus 20. And then if you do it for the other one, you'll get g is equals to minus 4. And then to finish this question off, then you just need to take these three answers and put them in for g, f, and c, and the same for these, and you get your two equations of a circle. Okay, so again, I have that done out for you there. This was just another exam question. We're not going to do it now, but it's just to show you kind of an easier version that I just thought I'd put into the PowerPoint for anyone who wanted to try it afterwards. You've got your 3 points on the circle. All you need to do is exactly what we did in the last question, except you just have 3 of them to sub in. So you'll have 3 equations, 3 unknowns, and you can solve them. And again, the solution is there for you. Another one, just to mention, the last kind of big thing I want to mention then for today is that if one of the clues that you're given is something to do with the center of the circle lying on a line. So sometimes it will say a circle has the point 1, 3, 2, 7, and its center lies on the line 2x plus y equals to 10. The big trick that you need to remember for that one is you substitute minus g minus f into the equation of that line for x and y, and that will give you your third equation, and you'll have your 3 equations with 3 unknowns, and you can solve them simultaneously. Okay, guys, so we're just after running out of time. So thank you so much for tuning in today. I just had one other exam question there that you can have a look at yourselves when you get your notes. So just remember, please fill in the forms document down the bottom if you want to if you would like to get the notes from today. Another reminder that we do have a discount code running until midnight tonight called Maths20. It will give you 20% off any subscription on our website. If you have found this useful, it would be brilliant to like and subscribe, or leave a review as well would be brilliant. And also, just to remember that we will be running further revision sessions. We've got an English one coming up on Saturday, and we will be looking into the possibility of running some Easter revision courses, but we'll be putting up more information on that on our social media, so do keep an eye on that. Just to show you the website then really quickly again, for anyone that would like any further support on the other things that we would have been looking at today, just have a look at our Leaving Cert page, go into your video tutorials, and in particular for any of the stuff that we did on the line and the circle. Obviously we've got loads of stuff done on that. You've got your line, you've got your circle, and again for your statistics and your probability, you can see that they're all in there as well. Okay, so high level statistics, and you can see I've done them all out in videos. So you've got your 95% confidence interval for the population proportion, the same for the population mean, and you've got your hypothesis testing done out there. And one thing that I didn't have time to go through today was p-values, so that would also be a really useful one to have a look at as well. Okay, I'm just going to have a really quick look now to see if there was any specific questions. Yeah, are we going to be doing any further revision? Yeah, so basically, guys, the plan is that we will hopefully be running some targeted Easter revision Zoom kind of classes, which will give you more information about. And I will also look into the possibility of maybe doing a few more YouTube lives on some kind of targeted topics. So again, maybe just do an hour YouTube live on trigonometry or something like that. So again, keep an eye on our social media. It would be great to know if you found today useful, and any feedback or anything else, feel free to send it through to us on any of our social media accounts. And we'll leave it there, guys. Thanks so much for tuning in, and I will see you next time.